Test trigonometric identities. Well, that is also a part of your test paper. It is an application problem for you. You need to prove sec to the power of 4x times 1 minus sine to the power of 4x minus 2 tan square x equals to 1. Copy the question, try to do it. Okay, we have a lot of identities similar to this. Now you need to put in your skills and get the solution. This is how I will like to do it. Now we can open the bracket. Let's start from left side. Okay, so let's start from left side. Now we'll open the bracket and we can write this as secant 4x minus secant 4x times sine 4x, sine to the power of 4x, minus 2 tan square x. Now, what is secant? Secant is 1 over cos. So let's write down this as sec 4x. So this is equal to minus 1 over cos to the power of 4x times sine to the power of 4x minus 2 tan square x. Now we get sec 4x minus sine over cos is tan, so we are left with tan 4x, right, to the power exponent 4 to tan square x. Now I hope you remember the trigonometric identity which relates tan and secant, right? The identity is 1 plus tan square x equals to secant square x, correct? If you don't remember, you remember how we derived it. You can always make a triangle here, and that's the opposite adjacent and hypotenuse. That's the angle x, right? And you know a square plus o square equals to h square. You need tan, so you need to divide opposite by adjacent, so divide by a square, right? So a square plus a square is 1. O over a is tan, so you get tan square x equals to h over a, which is secant square x. So that is the identity which I am going to use here, right? How? So I can take tan square x this side, correct? So it becomes secant square x minus tan square x equals to 1, correct? So that is how I'm going to use it. I'll show you. I cannot put in here because this is not squared. This is to the power of 4, right? So first I will use difference of squares. You remember difference of squares, which is a square minus b square is equals to a plus b times a minus b. So I'm going to use this first, okay? And so I can write this as secant square x plus tan square x times secant square x minus tan square x, right? Minus 2 tan square x. Now, secant square x minus tan square x is 1. So I'll replace this by 1, correct? So I'm left with secant square x plus tan square x times 1. So I need not write the bracket, okay? Because this is 1 minus 2 tan square x. Now tan square x minus 2 tan square x will give me tan square x. So I left with secant square x minus tan square x. And what is secant square x minus tan square x? Let me write here. So 1 is secant square x minus tan square x. So that is equals to 1, and that is what we wanted to prove, which is the right side. So that's how you do it. Okay? Thank you.